In today's lesson, we are defining average rate of change and instantaneous rate of change at a point. So, starting out, let's just talk about rate of change, which in Algebra 1, we also called slope. And to find that, we would just do change in y divided by change in x. And you probably learned this formula, the slope formula, where m is y2 minus y1 over x2 minus x1. So all we're doing is finding the difference of our y, the difference of our x, and dividing. So average rate of change, or AROC over an interval, it's the same thing. We just make it look fancier. So over an interval from a to b, those are our x values of a function. We would plug those in. So f of b minus f of a, those are our difference in y values, divided by b minus a. So let's do this for the function. We'll just do something simple. Y equals x squared. Let's find the average rate of change on the interval 2 to 6. So I need to do f of 6 minus f of 2 all over 6 minus 2. Okay, so plug in your x values to get your y value. 6 squared, 36. 2 squared is 4 over 4. So I've got 32 divided by 4, which is 8. So if we were to graph that x squared function from 2 to 6 on that interval, the rate of change is 8. Okay, so here looking at this parabola, we're going to look at a secant line is the line when we're connecting 2 points on a curve, connecting them, and essentially finding the average rate of change. So let's say this is on the interval from A to B. So finding the average rate of change of that parabola from A to B. So that is what we basically were just doing. So on the interval from A to B, f of B minus f of A over B minus A. Okay, now a tangent line is when we want to find that instantaneous rate of change at a point. So let's say at point A. Well, change at an instant doesn't really make sense because at an instant nothing is changing. What we're essentially asking is, what is the slope of this curve at the line tangent at that point A? Let's first think about how we can estimate it. Let's say we want to pick points on both sides of A. And we want to get a better estimate, so I'm going to get closer to A, and closer and closer and closer. So this change is getting smaller and smaller and smaller. So let's say this change from A, we want a really small change, and we're going to make this change h. So let's look at, I've got f of A, but plus this change of h, minus f of A, and then the change is h. So just to clarify, I'm not finding the difference between A and h, it's A and A plus h. Okay, so I want that change to get smaller and smaller and smaller. So what we're doing is we're finding the limit as the change h approaches 0. And as you can see, I can't just plug in 0 to my denominator, so we have to do a little bit of work. And we're going to do that in a couple examples in just a second. And then on your notes, I just wrote difference quotient just because that is what these are called. We've got a difference and a quotient. Okay, so I'm going to look at this function, f of x equals 2x squared plus 1. I want to find the instantaneous rate of change, which basically just means slope at the x value, -2. So if I have just a parabola, let's say this is at -2, what is the slope at -2? All right, and I'm going to use that formula, limit as h approaches 0 of f of a plus h minus f of a all over h. So a is the value that we want to find, the point in which we want to find that slope at. So what I'm going to do is plug in that -2 for a. So limit as h approaches 0, f of -2 plus h minus f of -2 over h. So I need to plug in -2 plus h into my function and -2 into my function. So limit as h approaches 0, let's see, 2, and then I'm plugging in -2 plus h squared plus 1, and then minus f of -2, which is 2 times -2 squared plus 1, all over h. So let's simplify. Limit as h approaches 0. I am going to FOIL that. I'm going to kind of flip those around. So I'm going to have 2, and then this will be h squared minus 4h plus 4. Don't forget this plus 1 minus -2 squared is 4, times 2 is 8, plus 1 is 9, all over h. Let's keep simplifying. Limit as h approaches 0. Let's distribute 2h squared minus 8h plus 8 plus 1 minus 9 over h. 8 plus 1 minus 9 is going to cancel. And I'm left with these two terms that have a GCF of h. They also have a GCF of 2, but I'm going to ignore the 2. I don't need to worry about that. Limit as h approaches 0 of h, and then 2h minus 8 all over h. My h's cancel. Now I can substitute that 0 in. 2 times 0 minus 8 is -8. Okay, so all of that. And did we forget what we were doing? -8. What does that -8 mean? That means that this function at this value has a slope that's like m is -8. That's the instantaneous rate of change at that value. Okay, I'm going to do another problem, and I'm going to show you another setup. So f of x, here's the function, equals 7 square root of x. We want to find the instantaneous rate of change. We want to find the slope of this function at x equals 2. So now look at these two formulas. So another way to write this, I can do the limit as x approaches a of f of x minus f of a over x minus a. So a reminder at the point a. So two different methods that essentially get us the same answer. So let's look. The limit, this time instead of as h approaches 0, it's as x approaches 2. And it's of f of x minus f of 2 over x minus 2. So f of x means I'm just going to put in the whole function. So limit as x approaches 2 of the function 7 square root of x minus, let's see, plug in 2, I'll have 7 square root of 2 all over x minus 2. I can't plug in 2 for x because I'll have 0 in the denominator. But I can simplify this. I've got square roots, so I can multiply by conjugates. So 7 square root x plus 7 square root 2. All right, so to multiply my numerator, I've got limit as x approaches 2. Multiply the top, so I've got 49 times x minus 7 times 7 is 49, square root of 2 times 2 is 2, so 49 times 2 would be 98, over x minus 2 times 7 square root x plus 7 square root 2. Okay, I can simplify the numerator by factoring. So I've got limit as x approaches 2. I can factor out a 49, which leaves me with x minus 2 over x minus 2 times 7 square root x plus 7 square root 2. Woohoo! Those cancel. So then I can plug in 49 over 7 square root 2 plus 7 square root 2. So 49 over 14 square roots of 2. And then I can divide those both by 7. So I'll have 7 over 2 square roots of 2. All right, once again, all that work, what did we just do? 2 square roots of 2. 7 over 2 square roots of 2. This function at this x value has a slope of that, or an instantaneous rate of change. Whew. So there's a lot to keep track when you're finding instantaneous rate of change using the limit definition. Now, good news is, after you have proven you can understand all of this, guess what we do? We teach you shortcuts, lots and lots of shortcuts. Of course, lots of shortcuts that you have to memorize. But that is your full video on average rate of change and instantaneous rate of change. Good luck with your lesson.